The table below shows the frequency distribution of corn plant height measured in field experiments carried out in EXU teaching and research farm. Compute the arithmetic mean, median, and the mode.
To solve this question, the first thing is to change your table to vertical form. You know, the table is in horizontal form where we have the height of the plant and the numbers of plant that ranges between each, right? So in that case, I make my height to be in vertical form and make the numbers of plant to be in vertical form also. Now after that, the next thing is to remember your formula. So this is the formula for calculating the arithmetic mean of a group data. Yeah, this is a group data because we have the class interval. The class interval, let me put it here, the class interval, which is the height. The class interval, that is the height. And we have the numbers of plants will be the frequency. So I will have the frequency in this place. The frequency is also the same thing as the numbers of plants. So this is a group data. Therefore, I cannot use the normal formula that we know, which is the sum of all the number, all over the count of all. You see, I cannot use this formula because this is a group data. Therefore, I can only use the formula of a group data to calculate the arithmetic mean. So this is not usable in this kind of situation, in this kind of question. We cannot use this. Now, the next thing is to find the value of x. Don't forget that we have known the value of frequency. Now, how do we calculate the value of x? The value of x is calculated by finding the midpoint of each class interval. Now, to get the midpoint of 30 and 39, I'm going to add 30 and 39 and divide it by 2. So let's add 30 plus 39 divided by 2. That is 34.5. So for this, I'm going to have 34.5. So that is how I'm going to get the value of x. The value of x is the midpoint of the class interval, and the midpoint is gotten by adding the upper class interval and the lower class interval and divided by the count of 2. So I'm going to have, for these cells now, I'm going to have 40 plus 49 divided by 2. I'm going to have 44.5. So for this cell, 44.5. So to get the value of x for these cells, I'm going to have 50 plus 59 divided by 2. So that is 54.5. For this, 64.5. 74.5, 84.5. Now we have gotten the value of x. From the formula, I still need the value of n. To get the value of n is the total numbers of the plants. And don't forget that the numbers of plants is also known as the frequency. So the total numbers of the frequency is the summation of 6, 7, 9, 11, 8, and 9, which will give me 50. So the total numbers of plants is 50. Now, if you look at this formula, I have gotten the frequency, I have gotten x. From the formula, I still need the value of fx, which is the multiplication of the frequency and the value of x that I just got here. So I'm going to have another table in that case. I'm going to multiply 6 multiplied by 34.5. 6 multiplied by 34.5, that is 207. So I'm going to have 207. And for these cells, I'm going to have 7 multiplied by 44.5. And 7 multiplied by 44.5, that is 311.5. So I'm going to have 311.5. So we are going to get the value of this other cell by multiplying this, by using the same approach. You just have to multiply the frequency with the x that you get. So after getting the value of fx, the next thing is to sum the value of fx. So I'm going to have the summation of 207, 311.5, 490.5, 709.5, 496.0, and 760.5. So after summing the value of fx, I have 3075. So I have gotten the value of summation fx and the value of n. So I can proceed to get the arithmetic mean. So the arithmetic mean is equals to summation fx, which is 3075 all over the numbers of the plants, which is 50. So that is over 50. So if you point your calculator, you are going to get 61.5. So the value of the mean for this data is 61.5. I want you to note something. If you calculate your mean and you realize that your mean fell between the class interval, which is not the high, which doesn't have the highest numbers of frequency, there is likely you might have made a mistake. For example, the highest numbers of frequency in this case is 11, and 11 belongs to the class interval between 60, between the range of 60 and 69, and the mean is 61.5. Therefore, the mean fell between the class interval with the highest numbers of frequency. So you have to take note of that. Now, the next thing that you are told to calculate is the median.
The formula of median is given by L plus into bracket n over 2 minus CFB all over FM multiplied by I, where L is the lower class boundary of the median class, n is the total number of observation, CFB is the cumulative frequency before the median class, and FM is the frequency of the median class, while I is the class width.
However, before I can use this formula, I need to get the class interval of the median class. The class interval of the median class is gotten from the cumulative frequency. Therefore, I'm going to have another column in this place where I'm going to calculate the cumulative frequency. To get the cumulative frequency of this cell, since there is no number before the frequency of these cells, so the cumulative frequency of this cell will be 6. So that will be 0 plus 6, which is 6. So for these cells, the cumulative frequency will be 6 plus 7, that will be 13. And for the next cell, the cumulative frequency will be 6 plus 7 plus 9, that will be 22. And for these cells, I'm going to have 6 plus 7 plus 9 plus 11. This is 33. And to get these cells, it will be the sum of the frequency before these cells. So I'm going to have 6 plus 7 plus 9 plus 11 plus 8. This will give me 41. And for the cumulative frequency of this cell will be 6 plus 7 plus 9 plus 11 plus 8 and plus 9. That is 50. So I have gotten the cumulative frequency. The next step is to divide the total numbers of plants, which is the frequency, all over 2. Therefore, I'm going to have n over 2 is equals to, don't forget, n is equals to 50. So I'm going to have 50 over 2. That is 25. The next step is to go back to my cumulative frequency and identify where 25 fell into. As you can see, 25 fell within this range. Therefore, the class interval that belongs to the range where 25 fell into on my cumulative frequency, that will be the class interval of the median class. In that case, since 25 fell around this place, which is within this range of 33, therefore the class interval of the median class will be 60 and 69. The class interval of the median class is 60 and 69. After getting the class interval, the next step is to get the class boundary. The class boundary is gotten by subtracting 0.5 from the lower class interval and adding 0.5 to the upper class interval. In that case, the class boundary, which is this, the class boundary, that will be 60 minus 0.5 and 69 plus 0.5. So the class boundary is 59.5 and 69.5. So the class boundary of the median class is 59.5 and 69.5 respectively. Now, after getting the class boundary, we can proceed to calculate the median by substituting all the parameters that we have already gotten into this formula. Therefore, the median is equals to, don't forget that L is the lower class boundary of the median class, and the lower class boundary of the median class is 59.5. So I'm going to have 59.5 plus n over 2. Don't forget that n is 50, and 50 divided by 2, that is 25. So I'm going to have 25 minus cumulative frequency before the median class. The cumulative frequency before the median class is 22. Don't forget that the cumulative frequency of the median class is 33. So the cumulative frequency before the median class, that is 22. So I'm going to have in this place minus 22 all over the frequency of the median class. The frequency of the median class is 11. So that will be all over 11. And multiplied by I. Don't forget that I is the class width, and the class width is gotten by subtracting the lower class boundary, which is 59.5, from the upper class boundary, that is 69.5. 69.5 minus 59.5, that is 10. So multiply by 10. So the median is equals to 59.5 plus 3 over 11 multiplied by 10. The median is equals to 59.5 plus 30 all over 11. Median is equals to 59.5 plus 30 divided by 11, that is 2.72. So the median is equals to 59.5 plus 2.72, that is 62.22. So the median is equals to 62. When you calculate your median and the value that you got as your median does not fall between the class interval of the median class, then definitely something is wrong with your solution. Because when we calculate the class interval of the median class, it fell between 60 and 69. And 62 is between the interval of 60 and 69. Therefore, this answer is correct. But if you calculate your median class and you realize that you didn't get the value that is between the 60 and 69, that is between the class interval of the median class, then what you have calculated is wrong. Now let us proceed to calculate the mode. Don't forget that the mode is given by this formula.
L plus into bracket delta 1 all over delta 1 plus delta 2 closing bracket C, where L is the lower class boundary of the modal class and delta 1 is the difference between the frequency of the modal class and the frequency before the modal class. Delta 2 is the difference between the frequency of the modal class and the frequency after the modal class. And C is the class width. Don't forget that the class width is obtained as a result of the difference between the upper class boundary and the lower class boundary.
Before we can use this formula, we have to determine the class interval of the modal class. The class interval of the modal class is the class interval that have the highest numbers of frequency. And if you look at this table, you can see that the highest numbers of frequency is 11. And the class interval to which the highest numbers of frequency belongs to is 60 and 69. Therefore, the modal class is 60. The modal class interval is 60 and 69. After getting the modal class interval from the formula, I still need the lower class boundary of the modal class. In that case, I need to get the class boundary of the class interval of the modal class. Therefore, I'm going to subtract 60 minus 0.5, and I'm going to add 69 plus 0.5. So the class boundary of the modal class is 60 minus 0.5, that is 59.5. And 69 plus 0.5, I'm going to have 69.5. So the lower class boundary of the modal class, that is 59.5. And the upper class boundary of the modal class, that is 69.5. From this formula, I still need the value of delta 1. Don't forget that delta 1 is the difference between the frequency of the modal class and the class before it. The frequency of the modal class is 11. So, and the class before it is, the frequency of the class before it is 9. So, delta 1 is equals to the frequency of the modal class, which is 11, minus the frequency of the class before it, that is 9. 11 minus 9 is 2. So therefore, delta 1 is 2. Now, from this formula, I still need the value of delta 2. Don't forget that delta 2 is the difference between the frequency of the modal class and the class after the modal class. That is the difference between the frequency of the modal class, which is 11. So I'm going to have delta 2 is equals to 11 minus the frequency of the class after the modal class, that is 8. So I'm going to have 11 minus 8. 11 minus 8 is 3. So I have gotten the value of delta 1 and delta 2. However, from this formula, I still need the value of C. Don't forget that C is the class width. And the class width is calculated by taking the difference between the upper class boundary of the modal class and the lower class boundary of the modal class. Don't forget that the upper class boundary of the modal class is 69.5 and the lower class boundary of the modal class is 59.5. The difference between 69.5 and 59.5 is 10. So therefore, C is equals to 10. Now I have gotten all the parameters that I needed in the formula. Now I can proceed to substitute all these parameters into this formula. Therefore, I'm going to have mode is equals to the lower class boundary of the major class, that is 59.5. Mode is equals to 59.5 plus delta 1. Delta 1 is 2. So I'm going to have 2 all over delta 1 plus delta 2, that is 2 plus 3. So I'm going to have 2 plus 3 multiplied by the class width. The class width is 10. So I'm going to have multiplied by 10. So which is M is equals to 59.5 plus 10 multiplied by 2, that is 20. 20 divided by 5. So mode is equals to 59.5 plus 4. Mode is equals to 59.5 plus 4. That is 63.5. So the mode of this group data is 63.5, which is approximately